there is a wire of length L is given that is bent in the form of a circle, and in that circle consider 2 points which are diametrically opposite. Between those 2 points, what is the effective resistance? In such case, what we are supposed to do is the points across which we need to find the resistance, connect a battery. When you connect a battery across those 2 points, you know that since these 2 points are diametrically opposite, this section of the wire and this section of the wire are equal in length. Hence, this portion and this portion will have equal resistance. Our aim is to find out this resistance and this resistance. We will be able to solve the problem. You know why? Because this length and this length are equal. If you try to redraw this, suppose when you connect the battery, it assume that the current is coming this way. Here at point A, the current divides into 2 parts. Then again, after passing through half the circle, they again come back and join here. You know that this section of the wire and this section of the wire are parallel to each other. So this can somehow be kind of redrawn into 2 pieces. You know that those 2 pieces are having equal resistances. If this resistance is R, this resistance will also be R. Then the effective resistance R effective will be R1 R2, which is R into R divided by R1 plus R2, R plus R. Effective resistance will be R square by 2R, which will be equal to half of that resistance. But what they have given indirectly is resistance of 1 meter wire. Resistance of 1 meter wire, they have given it to be 2 ohms per meter. So 1 meter wire having 2 ohms means 2 meter wire will have 4 ohms, and that means 2 times 2 ohms. So L meter wire will have L times 2 ohms. If we know the value of L, we'll be able to find the resistance of the wire. So when the wire is bent in the form of a circle, the radius of the circle have worked out to be 1 meter. If radius is 1 meter, the total length of the wire, you see this L only is bent in the form of a circle, right? Then the circumference of the circle will be equal to length of the wire. So length of the wire is equal to circumference 2 pi r. But radius of the wire, they have given it to be 1 meter. Then the length of the wire will be 2 pi meter. So if the length is 2 pi meter, resistance of the full wire equal to 2 pi meter into resistance per unit meter. So L into 2 ohms. So 2 pi meter into 2 ohms per meter. So this ohm and meter cancelled. So 2 times 2 pi will be equal to 4 pi. This ohm will be there, 4 pi ohms. So the total resistance of the wire is 4 pi ohms. In that, this is half, this is half. So this portion will have 2 pi ohms. This portion will have 2 pi ohms. Then as we said, if R is equal to 2 pi, this R is also equal to 2 pi, then the R effective will be equal to R by 2, that is 2 pi by 2. Hence when we cancel each other, that will be equal to 5 ohms. When a wire of length L having resistance per unit length 2 ohm per meter is bent in the form of a circle, when you consider 2 points which are diametrically opposite, then those 2 sections of the wire are parallel to each other. Then each portion, since the total length of the wire is 2 pi meter, then the total resistance of the wire will be 4 pi meter. Then each piece will have 2 pi ohms. Then R parallel, again you can work this out. So 2 pi into 2 pi divided by 2 pi plus 2 pi. When you work this out, you will get the answer as pi ohms. Hence, this is our option A.